Ever wonder what could be the most destructive force known to humanity? Let's embark on a journey into the world of theoretical science and imagine the unimaginable. Picture a weapon of such immense power that it dwarfs even the mightiest nuclear bomb. Enter the realm of the neutronium bomb. What is neutronium, you ask? Well, in the simplest terms, neutronium is a theoretical substance composed almost entirely of neutrons. It's the stuff that neutron stars are made of, and these celestial bodies are among the densest objects in the universe. To give you an idea of just how dense neutronium is, imagine compressing the entirety of our planet Earth into a sphere with a diameter of merely a few kilometers. That's the kind of density we're talking about. And with such extreme density comes equally extreme potential energy. But what makes neutronium truly fascinating and potentially terrifying is its potential as a weapon. The neutronium bomb is a concept that exists only in theory, but if brought into reality, it could unleash a power that's beyond comprehension. Such a bomb would not rely on chemical reactions or even nuclear fission or fusion, the processes that power our current nuclear weapons. Instead, it would derive its destructive force from the immense energy stored within the neutronium itself. And here's the catch. Neutronium is not a stable substance. If it were to be formed on Earth, it would instantly explode with a force far greater than any weapon we have ever seen. So, what makes neutronium so devastating? Let's dive into the science. To understand the power of a neutronium bomb, you need to grasp the science behind it. So let's dive into the cosmic depths of neutron star formation and the creation of neutronium. Imagine a stellar heavyweight, a star perhaps 8 to 20 times the mass of our Sun. When such a star exhausts its nuclear fuel, it undergoes a supernova explosion. This cataclysmic event ejects the outer layers of the star, leaving behind a dense core. This core, under the pull of its own gravity, collapses into a neutron star. Now, this isn't your typical star. Picture a sphere about 20 kilometers across, but with a mass greater than our Sun. It's so dense that a teaspoon of its material would weigh as much as a mountain. This is neutronium, the stuff of neutron stars, and the key ingredient in our hypothetical neutronium bomb. But how can something so small be so heavy? It's all due to the intriguing play of nuclear forces and gravitational binding energy. You see, under the extreme pressure and temperature in a neutron star, atomic nuclei are crushed together until their protons and electrons combine to form neutrons. The result is a sea of neutrons packed so tightly that they create an incredibly dense and powerful substance, neutronium. It's worth noting here that neutronium isn't something we can just mine from a star. It's created under conditions so extreme, they're almost incomprehensible. And if we could somehow bring neutronium to Earth, it wouldn't remain in the same state. Without the immense pressure of a neutron star, it would instantly explode with an energy greater than any bomb we've ever known. So, we've explored the birth of neutron stars and the creation of neutronium. We've touched on nuclear forces and gravitational binding energy, and we've begun to see just why a neutronium bomb would be so devastating. Now that we've got the basic science down, how would a neutronium bomb actually work? Imagine, if you will, the raw power of a neutronium bomb. In the realm of theoretical physics, neutronium is an ultra-dense substance composed almost entirely of neutrons, the neutral particles found in an atom's nucleus. This material is so dense that a sugar cube-sized chunk of neutronium would weigh as much as a mountain. Now, picture this. What if we could harness that immense density and energy into a bomb? To understand the potency of a neutronium bomb, let's first look at how it could theoretically work. When neutronium is freed from the extreme gravitational pressure of a neutron star, it would explosively decompress, releasing an astronomical amount of energy. This energy would come from the conversion of mass into energy, as described by Einstein's famous equation E equals EC squared. Now, let's put this into perspective by comparing it to a nuclear bomb, one of the most destructive forces we're familiar with. The atomic bomb dropped on Hiroshima in 1945 had a yield of about 15 kilotons of TNT. That's equivalent to the energy of 15,000 tons of TNT exploding all at once. In contrast, a neutronium bomb, even the size of a sugar cube, could release energy equivalent to billions of nuclear bombs. The destructive force would be so immense that it's hard to fully comprehend. Entire cities, even countries, could be wiped off the map in an instant. The energy release would be so great that it could potentially alter the very rotation of our planet. In essence, a neutronium bomb would not just be a weapon of mass destruction, but a weapon of planetary destruction. It's a concept beyond our wildest nightmares, taken from the depths of theoretical physics and hypothetical scenarios. The potential destruction is staggering, but what would happen if such a bomb were detonated on Earth? The detonation of a neutronium bomb on Earth is a scenario too terrifying to contemplate. Imagine the immediate impact zone, a vast area of destruction where the explosion's immense energy obliterates everything in its path. Buildings, trees, and all forms of life would be instantly vaporized. This is the unfathomable power of a neutronium bomb. Beyond the impact zone, the devastation would continue. A colossal shockwave traveling faster than the speed of sound would flatten structures and scorch landscapes for hundreds of miles. The intense heat and pressure would ignite wildfires, causing further destruction and loss of life. The detonation would also propel a massive amount of debris into the atmosphere. This debris, made up of dust and soot, would blanket the sky, blocking out the sun's rays. This phenomenon, known as a nuclear winter, could last for years, plunging the Earth into a deep freeze. The fallout from a neutronium bomb would be nothing short of global. Radioactive particles carried by wind currents would spread across the planet. These particles, when inhaled or ingested, can cause severe health issues, including cancer and genetic mutations. The radiation could also contaminate water sources and farmlands, leading to long-term food and water shortages. The environmental consequences would be equally catastrophic. The explosion would release vast amounts of carbon dioxide and other greenhouse gases, exacerbating climate change. The loss of biodiversity would be immense, with potentially millions of species being driven to extinction. The Earth's ecosystems, once diverse and vibrant, could be reduced to barren wastelands. And let's not forget the societal consequences. The detonation of a neutronium bomb could cause mass panic and societal breakdown. The recovery from such an event would take decades, if not centuries. The world as we know it would never be the same. The neutronium bomb is, without a doubt, a weapon of apocalyptic proportions. Let's recap what we've learned about the neutronium bomb. This intriguing and potentially devastating weapon has been the focus of our exploration today. We began by delving into the enigmatic nature of neutronium, the ultra-dense core of neutron stars. This substance, found only in the most extreme conditions of the cosmos, is what gives the neutronium bomb its name and its potential power. We've walked through the science that could, theoretically, make such a bomb possible. It's a blending of astrophysics and nuclear physics, a meeting of the cosmic and the quantum. We've discussed how neutronium, under immense gravitational pressure, becomes incredibly dense. This density is what could make a teaspoon of neutronium weigh as much as a mountain. And therein lies the potential for a bomb. If we were somehow able to harvest neutronium and keep it stable on Earth, it could be used to create an explosion of unprecedented scale. But as we've discussed, the challenges of doing so are immense, perhaps insurmountable. In the aftermath of such a detonation, we've speculated about the unimaginable destruction that could occur. We've painted a picture of devastation on a global scale, a cataclysm that could end all life as we know it. But it's important to remember that this is all theoretical. The neutronium bomb is a concept, a thought experiment, and not a reality. The hurdles to its creation are vast and many. We've explored a terrifying possibility today, but one that remains, thankfully, in the realm of science fiction. It's a sobering thought, isn't it? The neutronium bomb, a weapon that could end all life as we know it.